Howdy folks, 2 days ago on February the 22nd, 2025, I went ahead and released AutoNICER version 1.3.0, but that is not the main focus of this video. I will be going through some of the changes I made to AutoNICER with version 1.3.0, but really the main change or the main takeaway that I want this video to be more about, kind of like the primary focus of this video or this discussion, is I want to talk about when to use asynchronous requests versus synchronous requests. I think a lot of people fall into a bit of a pitfall in thinking that asynchronous is always better and it's always faster, and I've certainly done this before in the past. But just in my own experience doing this in enterprise environments, I make my living or I've largely made my living in writing code, and one of the things that I do quite a lot is kind of more like data engineering stuff, where it's like, get data from over here and, pipe it to somewhere else where they do maybe some type of enriching, and then it gets piped somewhere else, or you're just piping stuff from one place to another, whatever. So I'm very familiar with having to make requests, having to make a lot of requests, and thinking about how I go about designing software that is working optimally when we are requesting all different types of data and then piping it around to different places. So before I do get into that, I will say that AutoNICER version 1.3.0 has been pushed up to PyPI, so if you want to install it, just pip install AutoNICER and you'll be able to use it. Again, you do need to have a local version of HESoft and CalDB installed, because this is designed to live and work on top of HESoft, so you can check that all out for yourself in the README or in the wiki page. And if you need to upgrade to this latest version, it should just be as simple as running pip install --upgrade AutoNICER. Now, for those that are here only for the programming discussion, you don't care what AutoNICER is, you don't care, I will just say briefly to give you guys a little bit of background that AutoNICER is a CLI kind of pipelining tool that I built that allows for automated retrieval and preparation of data from NASA's NICER mission for people to analyze. I do analysis of that stuff. Obviously, I deal with getting a lot of this data, and the one thing that I think most people fail to understand when they're thinking first about should I use asynchronous or synchronous requests when I'm getting data is what is the actual data that I'm getting. So let's look at that first. In the case of NICER data, you can see that we are at this open directory right here, where we have this observation ID, and all of the contents of this directory being, of course, the observation ID 701.301.0107, is all of the individual files that live in each one of these subdirectories. So we have the log data, which is very, very small in nature. We have the auxil directory with auxil data, like the orbit, the filter file, the cat, and the attitude files. Really the only big one that's in here is the filter file at almost a megabyte in size. And then we have the XTI directory, which contains all of the merged and cleaned and unfiltered merged data, which is quite large. And if those of you who are watching this who do analysis with NICER, you know that if you deal with really, really bright sources like SCOX1, which is kind of like the most egregious case, these can be really, really large, in terms of gigabytes in size. Then, of course, we have the unfiltered data, which is again on order of megabytes. The housekeeping files are relatively small, but we've got all of these that we need to get as well. And then we also have the standard products, which aren't in every single observation ID dataset, but many of the newer observations do now have these standard products in here, and so we would want to probably get those as well, with really the biggest one being the RMF file. All of that together, again, makes up the entire observational dataset, and you're going to need all of that data if you want to do analysis of this data set, which is what I and many others are going to actually want to do. And so previously, with older versions of AutoNICER, I just used wget recursively to get all of this data. And if you go back to older versions like 1.2.7 or earlier, it just uses wget recursively because there's not a lot of overhead that I have to worry about. Wget's a good dependency, and you can use it recursively to get every single file in that in that entire data set like I just showed there. The problem with that is that all of that downloads synchronously one after another. So you're basically sending one request to the server and waiting for all of the contents of that to come back to you before you move on to the next thing. There are two questions I think we need to be asked, or two things that people need to consider when they're thinking about whether to use synchronous or asynchronous code. The first question is understanding what the physical limitations are. So if you need to get 1,000 things from one server, asynchronous stuff is probably not the best option for you, because you don't want to bog down that server with far too many requests in such a small time frame. You can use things like semaphore if you're doing this in Python with like async.io. That's going to limit the total amount of tasks that you can use, but ultimately still that's going to allow a lot of tasks to go in there in quick succession. And so limiting the total number of tasks that your program is handling at one point in time is relatively important to think about. Additionally, you want to think about the size of the data that you're getting. If you're getting really, really big responses or really big data files or data sets, like in this case, we're talking about, in some cases, gigabytes potentially, then using asynchronous code is not necessarily the best idea, because you also need to think about what are some of your limitations with regard to things like bandwidth. For me, with regard to AutoNICER, when I am doing research work and I'm analyzing this stuff, I do this at home. And I live in relatively rural America, and my download speeds are not as good as some of the people that I know that live in cities. I've got reasonably fast speeds at 250 to 300 megabytes of download speed, but I have plenty of friends that live in more rural parts of Wyoming, Montana, Idaho, South Dakota, and if they don't have Starlink, they're still on DSL that's like, at best, 10 megabytes a second. And so in that particular case, it wouldn't be the best idea to send out all of these requests all of a sudden, because you're going to be limited by bandwidth, especially if you're getting lots of data or big data sets for that matter. If you're getting big data sets, then you don't necessarily want to allow that to happen asynchronously, because you're going to get really, really slow speeds when you're trying to get that. Not to mention that you're going to have multiple requests sent out and multiple responses coming back in, and your bandwidth is not going to be able to handle that. But the other thing that you need to think about is, where are you actually getting this data from? In this particular case, with this NICER data, we are hitting this one server. As far as, I don't know what the HESARC's infrastructure looks like, but I'm just going to treat this as one individual source, and so I don't want to bombard it with a ton of requests in close succession. So the solution that I settled upon after a little bit of some testing, not really the best testing, but testing nevertheless with AutoNICER, is to switch to a asynchronous and synchronous approach, which is something I've used before in the past. In this case, we're dealing with one server, and we're dealing with some small data files and some larger data files. The larger files I'm going to get in a synchronous manner. That way, I'm sending one request to the server. The server only really, assuming I'm the only one that's using it, I know that's not the case, but assuming I'm the only one that's using it, it's handling my one request, and I'm not limited by bandwidth or anything else. That big file is the only thing that we need to worry about getting. All the smaller files we can get asynchronously. I set a megabyte as my threshold. Anything getting close to a megabyte in size, I said we're going to run that synchronously, and anything that is less than a megabyte in size, or a response that's going to be less than a megabyte in size, we want to deal with that asynchronously. So in that case, all of the cleaned event directory was done synchronously. Similarly, with the unfiltered data, all of this is on order of megabytes, so this is also retrieved synchronously, but the housekeeping files, all being kilobytes in size, this was done asynchronously, because although I'm sending a ton of requests to the server, it's not as many requests, and the amount of data it actually has to get and send back to me is not that much, and my bandwidth, certainly being the biggest concern, being in relatively rural America, can handle that. This is not the first time I've seen it to be really beneficial to split up requests into larger requests and smaller requests, run those larger requests synchronously, and then those smaller requests asynchronously. Also, especially when you're dealing with a single server, which is what I'm assuming is the case with dealing with this stuff from the HESARC. And so that covers the primary bulk of what I wanted to talk about in this video: when to use synchronous versus asynchronous requests, and just my experience with figuring out when to use both of those. And obviously, as I've already mentioned, the biggest change that I made to AutoNICER with version 1.3.0 is I dropped the wget dependency, and I'm not using it recursively, and I switched to using a combination of synchronous and asynchronous requests to get all of that NICER data. Additionally, one of the things that I did to get 10x performance, and quite literally 10x performance, I'll show you in a moment, is I ended up switching from using the HESARC's FTP servers here, and I switched to using the HESARC's AWS S3 buckets. So what you can see here is that when we try to when we use curl to submit a request to get the MPU7 cleaned event file from this particular data set with the FTP servers over at the HESARC, you can see that we get a download speed of about 3.2 megabytes per second. Very, very slow. It took like 40-some seconds. And no, that's not just a problem with my bandwidth here in rural America, because as you'll see here in a moment, when we issue the same request to the HESARC S3 bucket at AWS, we end up with a 42.3 megabyte download speed, and it downloads in about 3 seconds. It's going and getting it from the AWS S3 bucket by default. I haven't actually added in a way to get back to using the FTP servers, but if you guys want that, I can re-add that back in, or I can add in a little bit of functionality so that you can choose whether or not you want to use the S3 bucket or the FTP server. Other than that, on the previous discussion I made about AutoNICER with version 1.2.7 and the discussion about dependencies, as I already mentioned, I dropped the wget dependency, which is great. I'm happy I dropped that wget dependency, but I didn't rewrite anything specifically for Astro Query. I also kind of like to think that if something's not broken, you shouldn't try to fix it. And I sat down and was trying to, deal with thinking about whether or not I write my own querying software for querying the HESARC. And I said, you know what? The changes with Astro Query version 0.4.8 and 0.4.9 are really, really good, and I'm very happy with them. And so I just changed up whatever code I needed to get that back working. And so, again, just like I said in the last video, I'm very grateful for those changes to the HESARC module of Astro Query in version 0.4.8 and newer. And so, for the time being, AutoNICER is still using that. At some point in the future, I probably will write my own querying software for dealing with the HESARC, just because I rely on it enough. And actually, over this weekend, it was either the 21st or the 22nd, maybe the 23rd, I don't quite remember. But it was one of those days. It was like 1 in the morning, and Examin over at the HESARC went down with 404, where I was just getting a ton of 404 responses, and that lasted for a while, and I was like, damn it, this went down, and I need to access the NICER master catalog. I also needed to access like XTE master and a bunch of other things. I had a couple cron jobs fail. Anyways, I don't want to go on too much of a rant about that, but at some point I probably will do my own querying thing. But for the time being, the Astro Query dependency stays. I'm very happy that it's staying, because the new changes are quite good. I still maintain that internal solutions are always very good, but it's also something that I need to realize is that you can do anything, but you can't do everything, and so I need to limit my time accordingly, which this discussion is going much longer than I otherwise wanted it to. So anyways, AutoNICER version 1.3.0 is out now. Upgrade or download it if you're interested in that. Thank you very much for watching. I'm out.